Imagine, if you will, the Hoover Dam. Like, I want you to really picture it in your mind right now.
Okay, yeah, millions of tons of concrete.
Exactly. Millions of tons, thousands of workers, decades of meticulous planning, all of it just wedged into this massive, sweltering canyon to harness the raw power of a river.
Right, it's like a defining monument to the industrial age.
Totally. But now, take that mental image of the Hoover Dam and drop it right into the middle of a sleek, hyper-modern, humming Silicon Valley server farm.
Oh, wow, okay. That's quite a visual.
Right. You have the roaring water colliding with rows upon rows of glowing artificial intelligence processors. And here's the crazy part, we aren't stopping there.
Of course not.
Take that entire massive hybrid complex and airlift it straight into the freezing, rugged, unforgiving peaks of the Himalayas.
I mean, that sounds completely impossible.
It gets better. One more detail for you to visualize. Instead of thousands of human workers wearing hard hats and, swinging jackhammers, this entire colossal structure is being built by an army of autonomous, AI-coordinated robots.
It genuinely sounds like the opening scene of a science fiction blockbuster, like something out of a movie.
It totally does.
But what we were looking at today is not a movie script. It is a highly detailed, aggressively phased business roadmap.
Yeah.
And the core tension we are exploring in this deep dive is absolutely fascinating. I mean, on one side of the equation, you have the sheer brute force physical reality of building heavy infrastructure in literally one of the most brutal environments on Earth.
Right.
And then on the other side, you have the frictionless, hyper-accelerated world of artificial intelligence and software development.
And usually, those two worlds just do not mix.
Exactly. In the traditional world, those two domains completely clash. The slow physical world drags the digital world to a grinding halt.
Right, you're waiting on permits and concrete to dry.
Yeah, but the roadmap we are unpacking today proposes an entirely new paradigm. A system where the digital world actively builds the physical one at a speed we've never seen before.
Okay, let's unpack this right from the start because the scale here is just dizzying to me. I mean, most startups want to disrupt a very specific contained market, right?
Yeah, like an app.
Exactly. The cliche, someone builds a photo sharing app in a garage, gets some venture capital, maybe optimizes a local supply chain.
Right, something contained.
But this proposal wants to literally harness the Himalayas and build the digital equivalent of a planetary engine.
It's wildly ambitious.
It really is. So we've got our hands on a roadmap sourced from a June 2026 tech dispatch titled Netizen, Himalayan Compute, the next few steps.
Yeah, that's the one.
And this document outlines a multi-layered trillion-dollar moonshot. The underlying goal is to turn the nation of Nepal's completely untapped hydropower into the world's leading source of cheap, clean, frontier AI compute.
And our mission for this deep dive is to basically reverse engineer this incredibly audacious business plan.
Yes, let's tear it apart.
We are going to break down exactly how this proposed startup, which they call Himalayan Compute, intends to navigate international project finance, extreme geology, deeply entrenched bureaucratic gridlock, and the absolute bleeding edge of autonomous robotics.
Which is a lot to juggle.
It is. And if they pull this off, they achieve something entirely unprecedented in human history.
For sure.
But to really grasp why this is even being proposed, we have to start with the fundamental bottleneck of our current era, which is electricity.
Oh, man, yeah. The power problem.
Right. Artificial intelligence, particularly the massive frontier models operating in 2026, requires a staggering, almost incomprehensible amount of power to function.
Right. And I think we sometimes forget this when we use these tools on our phones.
Absolutely. It feels like magic.
It does. But every single time you ask an AI to generate a high-definition video or debug a complex piece of software or, simulate a protein fold somewhere in the world, a massive server rack is just burning through kilowatts of energy. And the global power grid is actively struggling to keep up with that demand. Like, we are running out of juice.
We really are. But then you look at Nepal.
Right.
This is a country sitting on an estimated 50,000 megawatts of untapped hydropower.
50,000 megawatts. That is just, it's hard to even picture.
It's massive, 50,000 megawatts. The pitch here is so elegant in its simplicity. You connect the world's most urgent problem, which is AI's massive energy starvation, with Nepal's greatest untapped natural resource.
It is an elegant thesis. I'll give them that. But execution is an entirely different beast.
No, for sure.
You don't just walk into a commercial bank in Manhattan Ask for $1 trillion to build robot dams in the mountains and expect them to hand over a check.
No, they would laugh you right out of the building.
Exactly.
Yeah.
Which makes me wonder, how does a project of this astronomical scale even get off the launch pad? Like, where do you find the starting capital for something that inherently requires billions to function?
Well, that brings us to the first highly pragmatic element of their strategy, which is the funding blueprint.
Okay, let's hear it.
If we examine the financial timeline mapped out in the roadmap, it does not start with sovereign wealth or massive venture capital rounds.
Really? I would have assumed they'd go straight to the big guns.
Nope. It actually starts with a highly targeted, very specific, and relatively tiny form of seed capital. They are looking to raise a starting runway of just $100,000 to $500,000.
Okay, wait, hang on. In the world of global nation-building infrastructure,
Yeah.
$500,000 is essentially finding spare change in your couch cushions.
There really is, yeah.
What does that actually buy you? I mean, a tractor?
It's not about the dollar amount. It is entirely about the source of those dollars.
Okay, I'm listening.
The plan specifically targets the South Asian diaspora. They are looking for 5 to 10 Nepali and Indian engineers or executives, and they specifically call out professionals working at massive hyperscale companies like Microsoft up in Seattle.
Oh, wait, Seattle?
Yeah, they want these specific individuals to write angel checks of about $100,000 each.
I am stuck on this detail. Why Seattle? Like, why a Microsoft engineer? Because if I have a wild, tech-adjacent moonshot, my first instinct is to take a flight to San Francisco, walk down Sand Hill Road, and pitch traditional Silicon Valley venture capitalists.
Right. Sure, that's the standard playbook.
So why bypass the VC ecosystem entirely for your seed round?
Because it acts as a brilliant, deliberate strategic filter.
Oh, interesting. How so?
By targeting South Asian diaspora engineers at major tech hubs like Seattle, Himalayan Compute instantly validates its business model with the exact demographic that deeply understands both halves of this highly complex equation.
Right. Okay.
Think about the psychology of an engineer at Microsoft or Amazon. They viscerally understand the AI compute bottleneck. They feel the data center constraints every single day at work.
Yeah, they're probably having meetings about server capacity all the time.
Exactly. They know exactly how desperate their employers are for power. Simultaneously, because they are of Nepali or Indian descent, they intimately understand the geopolitical and geographic reality of South Asia. They know what the Himalayas represent, they understand the cultural nuances, the local politics, and the sheer power of the rivers there.
That makes perfect sense, actually. If you take this pitch to a traditional San Francisco venture capitalist who has never left California, you probably have to spend the first hour of your meeting just explaining the geography of Kathmandu.
It really would.
And then, explaining the complexities of the Indian power grid before you even get to talk about the artificial intelligence part.
Yeah, their eyes would glaze over.
But if you pitch a Nepali principal engineer at a major cloud provider, you don't have to explain the context. They already live it.
Precisely.
They are a high-conviction investor from the very first slide of the pitch deck.
That's exactly it. It strategically de-risks the project at its absolute most fragile stage. That initial $500,000 is not meant to buy a single bag of cement.
Right.
It is purely runway. It is the capital required to incorporate the legal structures, polish the initial engineering blueprints, and bridge the company to a $10 million financing round.
Okay, that tracks.
And this is where the financial engineering becomes just as critical as the civil engineering. Because even with a $10 million bridge round in place, they aren't going to go out and blindly start pouring concrete in a valley.
Right, because $10 million still doesn't build a dam, not even close.
Exactly.
The roadmap outlines a very specific next move, right? Securing letters of intent, or LOIs, from mega customers.
Yes.
They explicitly name the hyperscalers, companies like OpenAI and Microsoft. The goal is to sell massive, bulk blocks of compute power that will be delivered in roughly 3 years, and each of these advanced commitments could be worth anywhere from $100 million to $200 million.
This is a classic maneuver in traditional project finance, but we are seeing it applied here to the frontier AI age.
Right.
For you as the listener, it helps to understand exactly how an LOI functions in this context. A letter of intent is essentially a highly formalized promise. It says, if you, Himalayan Compute, successfully build this data center in Nepal, and if you can guarantee this massive amount of compute at this specific, deeply discounted price, we legally guarantee we will buy it from you.
And if I'm OpenAI or Microsoft, this is a no-brainer. Like, I am starving for cheap, clean power.
Absolutely.
I don't care if it's in a desert or on a mountain.
Mhm.
If you can give me reliable watts at a lower cost than I'm paying in Virginia, I'll sign that piece of paper today.
Exactly. The hyperscalers take on very little risk by signing it. If the project fails, they lose nothing.
Right.
But for Himalayan Compute, those LOIs are the golden ticket. They provide guaranteed revenue visibility.
Yeah, because now you have proof of demand.
Exactly. When you can walk into a meeting holding a legally binding piece of paper from Microsoft that says they will definitely buy $200 million worth of your product in 3 years, suddenly you are highly bankable.
It changes the whole conversation.
It does. You take that piece of paper to the real heavyweights to unlock the debt and the multi-billion-dollar equity.
Which brings us to the actual heavyweights.
Yes, the big money.
Once you have the diaspora seed money validating the concept, the bridge round funding the operations, and the hyperscaler LOIs guaranteeing the future revenue,
Right.
you go to the sovereign wealth funds.
Some massive funds.
Right. The roadmap specifically targets funds from the United Arab Emirates. It lists ADIA, Mubadala, and ADQ. This is where billions come from to finance the full harnessing of that 50,000 megawatt potential.
Right.
But again, I have to ask, why the Middle East? Why not Wall Street, private equity, or massive infrastructure funds in London?
Well, we really need to look at the macroeconomic pivot happening in the Middle East to understand why the UAE is the perfect target here.
Okay, break that down for me.
These aren't just rich investors looking for a standard return. Sovereign wealth funds like the Abu Dhabi Investment Authority, ADIA, manage hundreds of billions of dollars.
Yeah, unimaginable wealth.
But more importantly, funds like Mubadala and ADQ have a very specific, aggressive mandate from the UAE government. Their entire purpose is to transition the national economy completely away from its historical reliance on oil.
Oh, so they are looking for the next big thing.
Exactly. To achieve that post-oil reality, they are making massive multi-generational investments in clean energy, cross-border infrastructure, and particularly the infrastructure that powers artificial intelligence.
So they have the infinitely deep pockets required, but they also have the exact strategic appetite for a project with this kind of timeline.
Exactly.
They want to literally own the infrastructure of the future economy.
Precisely. They represent patient capital. They are some of the very few entities on the planet that can write a $2 billion check for an infrastructure project that might take 10 years to fully mature.
Right, because Wall Street wants quarterly earnings.
Wall Street is impatient. The UAE sovereign funds are investing for the next century.
Okay, I need to throw a flag on the play here and do a reality check.
Sure, what's up?
If we zoom back down to the micro level, what does this massive influx of sovereign wealth mean for those early backers?
The seed investors.
Yeah. If I am one of those Seattle engineers and I wrote a $100,000 check on day one for a project that ultimately requires billions from Abu Dhabi just to break ground, aren't just throwing a pebble into the Grand Canyon.
You're worried about dilution.
Exactly. Won't my tiny slice of the pie get diluted into absolute oblivion once the sovereign wealth funds show up with their billions?
It is a totally valid concern. I mean, dilution is the classic innovator's dilemma in capital-intensive industries like aerospace or heavy infrastructure.
Right. You end up owning 0.001% of the company.
Right. But the roadmap calculates an incredible, almost staggering upside for those early backers. Their thesis is that those early $100,000 stakes could realistically grow to $100 million within a decade if the vision materializes.
Wait, 1,000x return on a physical infrastructure project.
That's the claim.
That sounds like software margins, not concrete margins. Like, how does that even work?
It does sound wild, but you have to understand what they are actually buying. They aren't investing in the concrete. They are investing in the foundational intellectual property, the sovereign agreements, and the operational structure of the company before the concrete is even a concept. They are buying the equity at a valuation of practically nothing. If this company successfully acts as the exclusive bridge between Nepal's vast rivers and the global AI economy, the valuation won't be calculated like a standard utility company.
Right. It's not the local power and light company.
Exactly. It will be calculated like a foundational tech monopoly. The roadmap notes that the initial core team, which they project to be under 10 people, stands to become billionaires.
Which is mind-bending contextually. I was looking this up before the deep dive. Nepal currently only has 2 billionaires in the entire country.
Yeah, exactly. 10 new billionaires in a country that only has 2. It completely rewrites the economic hierarchy of the nation.
Wow.
But as audacious as the financial engineering is, raising the money and promising the returns is only half the battle.
Oh, for sure.
You can't just take $1 billion from Mubadala, drop it on a snowy mountain peak, and expect an AI data center to magically boot up.
Yeah, gravity and weather still exist.
The terrain is brutal.
Yeah.
The logistics are a nightmare. So how do they actually plan to build this physically?
This is where we shift from the funding blueprint to what the strategy calls the two-wave execution strategy.
Right, the execution phase.
Because if you think about it from the perspective of a hyperscaler like OpenAI, if Himalayan Compute tells them, hey, give us your money, and in 10 years we will finish building a new dam and finally give you some compute, the hyperscaler will just walk away.
Absolutely. The AI industry moves at the speed of light.
They need compute yesterday, not in a decade.
Which is exactly why the first wave of the strategy is grounded in extreme operational reality. Rather than initiating new, massive dam construction on day one, Himalayan Compute plans to partner with existing hydroelectric projects that are already operating within Nepal.
Wait, existing dams?
Yes. They will deploy compact, highly efficient AI data centers directly adjacent to these existing power sources.
Oh, wow. This is brilliant strategic bypass.
It really is.
If you've ever followed a major infrastructure project, you know that building a new dam requires massive upfront capital expenditure CapEx.
Unbelievable amounts.
And before you even spend a dime on concrete, you spend years, sometimes decades, doing environmental impact studies, negotiating land acquisition rights, and fighting local zoning battles.
Yeah, it's a slog.
But Nepal already has dams that are happily churning out megawatts today. By co-locating modular, prefabricated data centers right next to the turbines at these existing sites, they dodge the immediate regulatory hurdles entirely. They just plug straight into the grid.
It serves as the ultimate proof of concept. It allows them to demonstrate to the hyperscalers and the sovereign funds that they can successfully operate in the unique conditions of Nepal.
Right, proving they aren't just vaporware.
Exactly. They prove they have the cooling technology dialed in for the altitude, they prove the power reliability, and they prove the network uptime. They deliver the cheapest compute on the planet almost immediately, generating early cash flow while the larger vision incubates.
That's incredibly smart.
And to manage this complex choreography, the roadmap details a very specific geographical split in their operations. They are establishing their primary command center in San Francisco.
Which feels a bit counterintuitive for a project in the Himalayas, like YSF. But the roadmap calls it an intentional nod to the tech ecosystem that birthed the AI revolution.
It's vital. They need to be physically present where the massive customers are, where the AI innovation is happening, and where the engineering talent for the digital twins and agentic AI resides.
That makes sense.
But the strategy explicitly notes that satellite command centers in South Asia will immediately follow. They outline what they call a capital talent fusion.
I saw that, Frit.
The plan is to aggressively recruit Indian and Nepali professionals, merging U.S. software experience with the brutal, pragmatic execution strength of South Asian engineering.
I love this concept. If you step back, they are essentially setting up a massive, real-time cultural and operational bridge.
Yeah, a bridge across continents.
Think about the specific components converging here.
Yeah.
You have San Francisco software ambition and agentic AI expertise.
Right.
You have Indian and Nepali engineering muscle, teams that actually know how to build in monsoons and high altitudes.
Yeah.
You have Gulf sovereign wealth pouring in the financial fuel. And all of this energy is being directed entirely at Nepali geography. It's a cross-continental machine.
It truly is the definition of next-generation globalized infrastructure. And this successful, parasitic in a good way, first wave, sets the stage and funds the transition to the second wave.
Which is the big one.
Yes. Hyperspeed execution and full vertical integration. This is the moment they evolve from being a smart data center operator into an actual massive energy creator. They begin developing their own sprawling hydroelectric facilities to finally tap into that broader 50,000 megawatt potential.
Okay, I have to stop us here. We need to talk about the elephant in the room.
The paperwork.
Or rather, the inescapable mountain of governmental paperwork in the room.
Yeah, it's a real problem.
You can have all the San Francisco ambition and UAE billions in the world, but building a massive dam anywhere on Earth, let alone in the ecologically sensitive Himalayas, takes decades of red tape.
Oh, absolutely.
You need environmental reviews, indigenous land rights negotiations, complex power purchase agreements, foreign direct investment clearances.
Just a nightmare of logistics.
If you've ever tried to get a simple municipal permit to renovate your kitchen or build a deck, you know it can take months of headaches. Now, I want you to imagine the sheer bureaucracy of asking a foreign government to let you dam a glacial river.
It's almost unimaginable.
Projects die in the approval phase. How does this startup survive the bureaucracy?
Well, the authors of this roadmap are acutely aware of that reality. They anticipate that exact bottleneck. They understand that unlimited capital and advanced technology are completely useless if they are trapped indefinitely in a government filing cabinet.
Right.
Their solution to this problem is not a piece of software or a new kind of turbine. It is a radical, almost shocking rewriting of how the host government itself operates. The roadmap describes regulatory speed not as a nice-to-have luxury, but as an existential requirement.
Existential, meaning if they don't fix the paperwork bottleneck, the company flat out dies.
Exactly. And this brings us to what might be the most fascinating non-technical innovation in the entire deep dive, the one-desk policy.
I am fascinated by this. Let's dive deep into the mechanics of the one-desk policy, because this feels like the linchpin of the entire trillion-dollar dream.
It really is.
The concept they are proposing is the establishment of a single, unified point of contact located physically or operationally within the Prime Minister's office, the PMO for every single required approval.
Everything goes to one place.
Right. Land acquisition, it goes to the desk. Environmental clearances, the desk. Power purchase agreements, the desk. Foreign investment routing, it all goes to one centralized authority.
And if we connect this to the broader historical context, Nepal's history with mega projects is typically characterized by multi-agency silos.
Like different departments not talking to each other?
Exactly. The Energy Ministry might approve a turbine, but the Forestry Ministry puts a hold on the transmission lines, and then the local provincial government objects to the road access. Projects die a slow death by 1,000 bureaucratic cuts.
Ouch.
By anchoring this new desk directly inside the Prime Minister's office, Himalayan Compute is intentionally elevating the project above departmental politics. It carries the ultimate, unarguable executive weight of the nation.
But they aren't just walking in and asking the Prime Minister for a massive favor, like, hey, can you fast-track this? There is a structural, heavily incentivized trade-off here.
Oh, yeah. Big time.
The roadmap states that the government of Nepal receives a direct 10% equity stake in Himalayan Compute explicitly in exchange for implementing and strictly enforcing this policy.
Which represents a profound shift in traditional infrastructure incentive structures. Historically, a foreign infrastructure company views the host government as a toll booth, a slow, frustrating obstacle that must be managed, appeased, or bypassed.
Right, a necessary evil.
Here, Himalayan Compute is making the sovereign government a literal co-founder. By granting them 10% equity, the national financial incentives are perfectly aligned with the private company's execution speed. The government literally profits from moving fast.
But they want to get it done just as badly.
Yes. If the company achieves that trillion-dollar valuation over the next decade, the government's equity stake is worth $100 billion.
Let me put that in perspective for you.
Yeah.
Nepal's entire national GDP right now is roughly $40 billion.
A 10% stake in a successful Himalayan Compute could single-handedly double or triple the wealth of the entire nation.
That is an absurd incentive.
And they know that promises fade, so to ensure this one-desk policy isn't just an empty political gesture, the specific mechanics are strictly codified. They demand rigid service level agreements, or SLAs, for every type of permit.
Right, putting it in writing.
They require the creation of fully digital portals for all submissions to eliminate physical paper trails, which famously get lost or delayed. And crucially, the absolute core of this policy is the requirement for deemed approvals.
I love this concept. Deemed approvals. Let's explain how this works. It means if the government has, say, a strict 30-day window to review an environmental permit, and day 31 rolls around with no formal answer, the permit is automatically legally approved.
Yep, it's a digital stopwatch.
The digital stopwatch is absolute.
Yes, it entirely flips the psychological burden of bureaucratic delay. In a normal government setting, delay defaults to no or wait. With deemed approvals, delay defaults to yes. The roadmap points out that this isn't entirely without precedent globally. It highlights India's single desk system, specifically pointing to the state of Andhra Pradesh.
Oh, interesting.
They implemented 21-day auto approvals, and it was wildly successful in attracting major time-sensitive data center investments. It also acknowledges that Nepal has attempted one Windows service centers in the past, but they ultimately failed because they lacked the high-level PMO enforcement and, crucially, the massive financial equity alignment this new proposal brings to the table.
Okay, I have to jump in and play devil's advocate here because my alarm bells are ringing loudly.
Bring it on.
This sounds amazing on a Silicon Valley whiteboard, but in practice, you are giving the government a 10% equity stake in a private, for-profit enterprise to fast-track your paperwork.
Right.
That doesn't just look like a red flag to me. That looks like a recipe for a massive geopolitical scandal. It sounds like straight-up legalized cronyism. What happens to any local competitors?
It's a very real concern.
And furthermore, the roadmap explicitly mentions the sensitive Himalayan ecology. If you put vital environmental and social approvals on a relentless digital stopwatch, don't you risk bulldozing right over crucial ecological safeguards just to hit an SLA? Like, how does the roadmap possibly defend this as a responsible idea?
Well, it is the most critical critique you could make of the entire document, and to be perfectly fair to the source material, they do not hide from it. The roadmap actually acknowledges these exact risks head-on.
Okay, so they know it's controversial.
Yes. This isn't presented as a flawless, risk-free utopia. They explicitly list the severe challenges maintaining political sustainability across highly volatile Nepali election cycles, the very real and present danger of compromising genuine ESG, environmental, social, and governance safeguards in the name of speed, and the inevitable public perception of favoritism or corruption.
So if they know it looks like cronyism and risks ecological damage, how do they justify moving forward? Like, what's their defense?
Their defense relies entirely on a system of radical transparency.
Transparency, okay.
The strategy calls for public, real-time dashboards tracking every single permit and approval, transparent penalties for delays, and performance-linked incentives that are visible to the public.
So everyone can see what's happening.
Exactly. The massive gamble here is their belief that by making the entire process digitized and publicly trackable, that transparency, coupled with the sheer scale of the shared national wealth generated by the 10% equity, can outpace traditional corruption.
That is a big if.
It's a huge if. It's an attempt to design an operating system for a country where doing the right thing quickly is measurably more profitable for everyone involved than doing the wrong thing slowly in the shadows.
It's a massive high-stakes gamble. But, for the sake of exploring the rest of the roadmap, let's assume it works.
Okay, let's assume.
Let's assume the one-desk policy miraculously clears the legal runway at warp speed. The ink is dry, the permits are auto-approved, the land is secured. We instantly hit a brand new physical wall. Yes. Human construction workers simply cannot build massive concrete dams and hyperscale data centers fast enough to keep up with that kind of legal velocity. If your paperwork is moving at the speed of software, how do you possibly match the physical pouring of concrete to the legal speed?
This is exactly where we transition from the bureaucratic hack to the physical execution, and this is where the deep dive into the second wave gets truly futuristic.
This is my favorite part.
To match hyperspeed legal clearances, Himalayan Compute plans to deploy hyperspeed construction. We are talking about the full-scale, integrated deployment of artificial intelligence, agentic systems, and heavy robotics.
The roadmap outlines a very specific hardware and software stack for this. Their goal is to completely solve labor shortages, human safety risks, and the absolute necessity for 247 continuous operations in the Himalayas.
Right.
Because, let's face the biological reality, human beings are fragile. We get tired, we need to sleep, we need to breathe oxygen, which is thin at altitude, and we get dangerously cold. The Himalayas are unforgiving.
Exactly. Traditional human-led construction in this region is severely handicapped. You are limited by daylight hours, you are stopped by seasonal weather patterns like the heavy monsoons, and you are constantly managing extreme lethal danger.
Yeah, avalanches, pulse.
Landslides, seismic activity, altitude sickness. In that environment, human flesh and bone is a major liability.
So enter the robots.
Yes, enter the robots.
The document mentions a fascinating multi-tiered lineup of hardware. First, they plan to use autonomous heavy equipment from established incumbents like Caterpillar and Komatsu. We're talking about massive dozers, excavators, and haul trucks that utilize AI, advanced computer vision, and high-precision GPS to move Earth-in-grade terrain with absolutely zero human drivers sitting in the cab.
It fundamentally changes the risk profile of the entire mega project.
Oh, so?
Think about it. A landslide hitting a human-driven excavator in a remote valley is a tragic loss of life that stops a project for months.
It's devastating.
But a landslide hitting an autonomous excavator is just a line item on an insurance claim. You clear the debris with another robot and keep working.
Wow, yeah, that's a cold but very real calculation. Then, for the actual construction of the data centers, they mentioned specialized layout robots. They specifically named Dusty Robotics and their field printer system.
Oh, this tech is so cool.
For those who aren't in architecture or construction, you need to understand how cool this is. They use robots to print BIM layouts, building information models.
Right.
BIM is essentially a hyper-detailed, data-rich 3D blueprint of a building. This robot drives around a massive, empty concrete slab and prints the entire architectural blueprint directly onto the floor at 1/116th of an inch precision. It tells you exactly where every pipe, wire, and wall goes.
It completely replaces teams of human surveyors pulling tape measures and snapping chalk lines. It operates 10 times faster and entirely eliminates the human error that usually leads to incredibly costly rework down the line.
Oh, totally. Measure twice, cut once.
Exactly. If a pipe is laid 2 inches to the left because a human misread a blueprint, you might have to tear down a wall later. The field printer ensures mathematical perfection from the foundation up.
And then we get to the piece de resistance of the roadmap. Humanoid robots.
Here we go.
The strategy cites Boston Dynamics Atlas, specifically the fully electric humanoid with 56 degrees of freedom. They want these machines doing dynamic, complex material handling in highly unstructured, messy environments.
Let's spend a moment exploring exactly how this works, because the mechanics are what make it revolutionary. It comes down to a concept called fleet learning.
Fleet learning, okay.
Imagine you have a fleet of 50 Atlas robots working on a dam. One of those robots encounters a highly specific edge case, say. It tries to carry a heavy steel beam across a patch of black ice on an uneven mountain pass, and it slicks.
Okay, natural mistake.
In a human workforce, maybe that worker warns his buddy, but the knowledge is localized. With fleet learning, the moment that robot's neural network figures out the optimal micro-adjustments in its joints to regain balance on that specific ice, that data is instantly uploaded to the cloud.
Wait, and shared with the others.
Exactly. It's shared with every other robot in the fleet. They get smarter collectively in real time. Every mistake makes the entire hive mind flawless.
That is incredible. And overseeing all of this, the caterpillars moving the dirt, the dusty bots drawing the precise lines, the Atlas humanoids adapting to the ice is what the roadmap calls the command layer.
The brain.
Right. It's an agentic AI system coordinating predictive maintenance, adaptive scheduling, and real-time monitoring against digital twins of the project.
Yes, and we need to clearly define what a digital twin is in this context. A digital twin isn't just a static 3D model on a computer screen.
Okay, what is it?
It is a live, data-fed, perfect virtual simulation of the construction site. As a robotic paver pours concrete in the real world, sensors and drones update the virtual model instantly.
Oh, well.
If the real-world pour is off by 2 millimeters, the overarching AI detects the discrepancy in the digital twin and automatically course-corrects the robot on the fly. It constantly compares the physical progress against the mathematically perfect digital model, adjusting the schedule of thousands of machines second by second.
It's blowing my mind. It sounds like playing a real-time strategy video game, but with actual heavy machinery in a mountain range.
It really does.
But I have to ask, has anyone actually done this in the real world? Or is this just highly optimistic venture capital vaporware? Has anyone successfully built a dam with an army of robots?
Yes, they have.
Wait, really?
Yes, and the roadmap points to a highly specific landmark precedent that proves this isn't just theory. China's Yangpu hydropower dam.
Right. I was reading about this in the source material. The Yangpu Dam is located on the Tibetan Plateau.
Yep.
For context, this is a 180-meter tall dam that's roughly 590 feet of sheer infrastructure, and it is currently being built by a centralized AI system. The AI orchestrates massive fleets of unmanned vehicles, excavators, pavers, rollers. It is essentially building this massive dam layer by layer, almost like a giant valley-sized 3D printer with almost zero human labor actively on the construction site.
This is the crucial, undeniable proof of concept that Himalayan Compute is relying on. The Tibetan Plateau shares many of the exact extreme geological, weather, and altitudinal challenges of the Himalayas.
That's a perfect test case, then.
It is. The Yangtze project proves definitively that an AI can optimize material placement and compaction far better than human operators. Think about a human driving a steamroller. They get bored, they get distracted, they vary their speed.
Yeah, human error.
But an autonomous steamroller doesn't get distracted. It applies the exact mathematically required pressure perfectly evenly for 24 hours a day. It takes a multi-year, highly dangerous, unpredictable project and turns it into a relentless, mathematically perfect machine.
So, if I'm picturing this right, they aren't just building a dam in the traditional sense. They are turning the entire Himalayan construction site into a giant, self-contained outdoor robot factory. It is a closed-loop system of creation.
Exactly.
But wait, I see a glaring logical flaw here.
Okay, sure.
Bringing a massive fleet of Boston Dynamics humanoids and electric caterpillars to the Himalayas sounds wildly, incredibly expensive up front. But more importantly, do they even have the electrical infrastructure to charge these robots before the dam is actually built?
Ah, the chicken and egg problem.
Exactly. It feels like an impossible chicken and egg problem. You need massive amounts of electricity to charge the robots that are supposed to be building your electricity plant.
It's a brilliant observation, and the roadmap actually addresses this exact irony directly.
Right.
This chicken and egg problem is precisely why the first wave exists.
The parasitic first wave, partnering with the existing dams.
Exactly. The high upfront capital and the desperate need for reliable power in remote, high-altitude areas are solved entirely by the first wave. Remember, they start by negotiating partnerships with existing hydropower plants to build those initial compact data centers.
Right.
Those early operations generate the vital cash flow. They prove the operational model to the skeptical sovereign wealth funds, and crucially, they provide the initial stable electrical grid needed to power the base camps and charging stations for the robotic transition.
Okay, that wraps it up perfectly.
Furthermore, the strategy realistically notes that we will not see a 100% autonomous robot workforce on day one. It explicitly states that hybrid human-robot teams will be the realistic, messy, near-term solution before the full autonomous fleets and fleet learning algorithms mature over the next few years.
Okay, I am just marveling at the synthesis of this entire plan. Let's pull back from the microscopic details and look at the whole board.
Let's do it.
You start with tiny seeds of diaspora money from a few high-conviction engineers in Seattle. You use that specific runway to validate the model and secure legally binding LOIs from desperate hyperscalers like Microsoft.
Right.
You use the guaranteed revenue of those LOIs to log in billions from UAE sovereign wealth funds looking for a post-oil future. Meanwhile, you bypass decades of Nepali bureaucracy by giving the government a 10% equity stake to set up a ruthlessly efficient one-desk policy in the Prime Minister's office with deemed approvals.
Yep, the timeline compresses.
And finally, you execute the physical construction at hyperspeed using an army of AI-coordinated self-learning robots.
It is, without a doubt, a breathtaking logistical and financial symphony.
But what is the ultimate endgame here? Because if you actually pull all of this off, you are no longer just a clever startup operating data centers. You are something else entirely.
And this is where the roadmap moves into its final phase, the trillion-dollar trajectory and the global macro impact. The document makes it explicitly clear Himalayan Compute does not view itself as just a Nepali company built solely for the benefit of Nepal.
No. What are they aiming for?
It aims to be a foundational global enterprise. It is utilizing Nepal's unique geography to create a completely new, exportable model of cross-continental infrastructure.
The scale of the ambition in this final section is wild. The text states their ultimate goal is to deliver sustained triple-digit growth rates for Nepal's national economy. Triple digits. That means doubling the entire country's economic output year after year.
If achieved, it would be a case study taught in economics textbooks for a century. Going from a $40 billion GDP to hundreds of billions in a decade alters the destiny of millions of people.
Absolutely.
And they plan to embed themselves deeply into the nation's financial fabric to ensure this happens. The project includes supporting the government of Nepal in issuing sovereign infrastructure bonds.
So not just company stock, but national bonds.
Exactly. These bonds wouldn't just fund their specific dams. The capital would accelerate the building of national highway roads, high-voltage transmission lines, and ancillary civil projects across the country.
So they're essentially underwriting and managing the rapid modernization of the entire country.
Yes, and this fundamentally reframes Nepal's position on the global stage. For decades, Nepal has largely been viewed by the international economic community as a passive recipient of foreign aid, or an economy heavily reliant on remittances from its citizens working harsh jobs abroad.
Right.
This project transforms Nepal from a passive player into an active, globally critical enabler of the AI revolution.
It's like they're trying to single-handedly upgrade a country from the industrial age straight into the artificial intelligence age,
Yeah.
completely skipping several developmental steps in between.
That's a great way to put it.
And they are doing it by perfectly aligning everyone's inherent greed and ambition. Think about the players. The hyperscalers get the cheap compute they're desperate for to win the AI arms race.
Yeah.
The UAE gets the long-term post-oil investments they need for survival. The early Seattle engineers get a chance to become multi-billionaires. And the Nepali government gets a booming triple-digit growth economy and world-class infrastructure.
That perfect alignment of incentives is the secret sauce of the entire roadmap. The strategy notes that by deciding exactly where to build this massive compute capability, Himalayan Compute acquires what it terms geopolitical gravity.
Geopolitical gravity. I like that.
When a single private entity controls tens of thousands of megawatts of frontier AI compute, your infrastructure decisions actively influence global energy markets. You dictate technological dominance, and you create massive new economic corridors across continents.
Wow.
Furthermore, the document strongly hints that Nepal is just the proving ground.
Right. The roadmap says they have no intention of stopping at 50,000 megawatts in Nepal. Future phases look far beyond hydropower, explicitly expanding into space-based compute systems, massive solar arrays, and other high-potential, untapped regions worldwide. It's essentially a template for what they call the Age of Abundance.
It is a profound blueprint for how private capital, artificial intelligence, and untapped natural resources might completely reorganize the geopolitical map over the next 50 years.
Okay, we need to wrap up this massive, sprawling scope. We have spent this deep dive exploring how this audacious roadmap, Himalayan Compute, plans to single-handedly solve the AI energy crisis.
It's a huge topic.
They are proposing to marry the wild, untapped rivers of Nepal with U.S. software ambition, pragmatic Indian engineering scale, and the deep pockets of Gulf sovereign wealth. They are proposing an unprecedented 10% equity hack to fast-track glacial government bureaucracy, and they plan to physically build the future using fleets of self-learning AI construction robots. It is a massive amount of information to take in.
It is a lot to process, and as we conclude, I want to leave you, the listener, with a final thought to ponder. It's a thought that builds directly on the inherent tension between bleeding-edge technology and ancient nature that we've discussed today.
Okay, what is it?
The roadmap proudly mentions that advanced AI will be used to meticulously monitor the delicate environmental and ESG safeguards while building these massive dams. The AI will be tasked with watching over the Himalayan ecology.
Right, ensuring the robots don't destroy the environment while they build.
Exactly. But I want you to really consider this scenario. If you have a massive autonomous robotic fleet controlled entirely by an agentic AI, and that AI's core fundamental programmed directive, its reason for existing, is hyperspeed construction to achieve triple-digit economic growth.
Okay.
How do you actually ensure that the AI doesn't eventually prioritize its directive for speed over the very ecology it is simultaneously supposed to protect?
Oh, wow.
If the AI calculates with cold mathematical precision that temporarily ignoring an environmental safeguard will compress the construction timeline by 6 months and save $1 billion, what choice does the machine make? We're building an AI to power the future of AI. What happens to the natural world when the machine is entirely in charge of building its own power source?
That is a genuinely haunting question to leave us on. It is the ultimate real-world test of aligning artificial intelligence with human values. But instead of playing out in a software simulation, it's playing out with millions of tons of concrete and steel on the roof of the world.
Absolutely.
Thank you for joining us on this deep dive. We hope you walk away with a new perspective on the scale of what's coming. Keep questioning the massive infrastructure shifts happening quietly in the background of the tech world. Because before you know it, the digital revolution isn't just an app on your phone. It's physically reshaping the rivers, the economies, and the mountains around us. Until next time, remember you might just be looking at the blueprints for the Hoover Dam of the 21st century, and the robots are already booting up.